Hello, this is Brandley Miller presenting Understanding Antennas. So a little bit of an overview. A transmitter establishes a voltage across the antenna. This applied voltage forces charge carriers to move. This motion produces an alternating current in the conductor, and then the alternating current produces time-varying electric fields. These changing electric fields extend outward from the antenna, and these electric fields simultaneously generate magnetic fields. The coupled up electric and magnetic fields form electromagnetic waves, and these waves propagate away from the antenna into free space, and the waves carry both energy and modulated information. The antenna is built up to resonate at a specific operating wavelength. Resonant length is typically a fraction of the signal wavelength, and resonance improves radiation efficiency and reduces power loss. Passing EM waves induce a voltage in a receiving antenna. This induced voltage drives a small alternating current. The received signal then processed into usable data. So kind of the steps here for signal conversion. The first one being voltage oscillation. The transmitter generates an oscillating voltage at the feed point of the antenna, and then this voltage establishes alternating electric potential on the antenna. Second step being induced alternating current. The voltage difference forces charges in the conductor to move back and forth. This motion forms an alternating current that follows the signal frequency. And then lastly, radiation of the electromagnetic waves. The alternating current produces time-varying electric and magnetic fields. These coupled fields detach and propagate outward as electromagnetic waves. A little bit of history here. James Clerk Maxwell, he formulated Maxwell equations, which we'll talk about later, that ties 303 to this topic. He predicted the existence of electromagnetic waves, which antennas radiate and receive. Hertz first to experimentally generate and detect EM waves in a laboratory. This confirmed Maxwell's theory. And then Marconi built the first practical radio communication systems using antennas and achieved the first transatlantic wireless signal, proving long-distance radio was feasible. So what's the difference between FM and AM radio? AM and FM are two common methods used to transmit information using radio waves. In AM, the amplitude strength of the carrier wave is varied in proportion to the audio signal, which we can see here. In FM broadcasting, the frequency of the carrier wave is varied, with the amplitude remains constant. So you can see here the amplitude of this wave stays the same. But the AM radio operates at lower frequencies with longer wavelengths, requiring larger antennas, while FM operates at higher frequency with shorter wavelength, allowing for more compact antenna design and improved signal clarity. So how this relates to 303, back to Maxwell's equations, describe how electric fields and magnetic fields interact and propagate. So the two key principles of why this is directly power antennas. A changing electric current creates a changing magnetic field, and a changing magnetic field then creates a changing electric field. So together these form a self-propagating electromagnetic wave that travels through space at the speed of light. And an antenna is simply a device that forces charges to accelerate, which is exactly what Maxwell tells us will produce radiation. And here are my sources.